everyone, and welcome to this video, a special video where we will introduce some concepts that are used in chemistry, physics, and another kind of science. This concept is concept of operator. Put like in this video, share this video with your friends needing help in this kind of content. Also subscribe in our channel. And as I introduce it, today we will talk about operators, which is a mathematical concept that we apply in many scientist area. For today we'll talk about the concept of operator. We'll talk about different kind of operators, different kinds of operators. We will also talk about operations with operators. About the different kinds of operators, we'll talk, for example, about multiplication operator or multiplicative operator. We'll talk about a square root operator, differential operator, integral, and matricial operators. About operation with operator, we'll talk about sum of operators. We'll talk about identity operator, equality of two or more operators. We will talk about product of operators. We'll talk about a commutator, and in the end we will talk about the inverse operator or the inverse of n operators. As a start point, we will talk about the concept. Then here n operator is a mathematical object, for example A, that acting on a general function f, we get another function g. Mathematically, we can write operator A acting on a function f, we get a function g. This operator can be of different kind, where, for example, we have here different kinds of operators. We begin with the first one, which a multiplicative operator. Suppose, for example, we call a multiplicative operator u of x, for example, or I will has a general function, an operator u acting on a function f to get a function g. This here we have a multiplication, and we can use as example here, for example, our u operator is a function of x which is equal to x, for example, and f, a function f is a function which is equal to x squared. Then when we apply the operator u of x to a function f, we get x times x power 2, which is equal to x cubic. Okay, then we have here u has a multiplicative operator. On the other hand, we can have, for example, a square root operator. Suppose now we have here we are talking of square root of operator, sorry, here. Okay, suppose for example our function again is f equal to x squared, and our operator a is equal to square root, so that a acting on a function f, we have a square root of x. And here we can see that if we substitute a function with its corresponding, we have here square root of x squared, which is equal to module of x has the solution. Then you have here a has the square root operator. On the other hand, we can have a square of or nth square with, for example, the operator has nth square. And also we can apply to get different results acting the b operator on different kinds of functions. Okay, we go on talking about the differential operator and integral operator. Okay, differential operator. Okay, this, has the name tells us, is a differential where then we, for example, we have has example a, or I can say c of the operator c, it's equal to d over d of y, and our g function is g of, we can say g of x and y, which is equal to x squared times y. Then we have that when we act c on a function g of x and y, we get d over d of y of x squared y. And we can see here this derivative is about y, so that for our function x squared y, the x squared is a constant, and we can take out from the derivative, and we get only x squared d of y over d of y, which is this is equal to 1, and we get only x squared. Then we have here c has a differential, has an example of a differential operator. The same thing we can think about the integral operator. Okay, integral operator, where we can, for example, here have the operator, not I but the, which is equal to integral of h of x y d of y, where here we call this operator in integral nucleus. And suppose that our g function, for example, or let me put here f of x function, no, f of y, and we have this function, yeah. Then when we act the operator on f of y, we have integral of h of x and y acting on a function f of y d of y. As we can see here, we are integrating as a function of y. Yes, maybe here we okay, I will say we get here a function g of x and y. Okay, we go on. We go with the other. For now we have the matricial operator. Okay, we have matricial operator. Okay, what actually we know about matrix? A matrix A is a list of elements given as A11, A12. So we go on until reach the element 1, and where okay we have the other elements to A21, A22. We go on until the element A2n, and here we go on until the element M1, A, M2, and we go on until reach the element M, AM, N. Okay, we call this has a line. Then we have this has the first line, this one the second line. We go on until reach the last line. This is the mth line. Okay, on the other hand, we call this has column. We have the second column. This is the first column. We have the second column, and we go on until reach the nth column. Then we say that our matrix A is has the order m times n, where m represents the number is the number of lines, and n represents the number of columns. Okay, the number of columns. Okay, and we know that two matrices we can take the product of two matrices. For example, here, yeah, we can take the product of two matrices A and B if the number of columns of the first matrix A, is equal to the number of lines of the second matrix, so that this product will be equal to a matrix C with M lines and L columns. Okay, then we can see here actually that this is the first matrix is N matrix is a matricial operator. We have, for example, if we have A, right hand has A11, A12 until AN, here A21, A22 until A2N, go on until AM1, AM2 until AMN, and we have, for example, the column matrix, which is B11, B21, go on as we say here. We have, for example, BN1. Okay, then we can take the product of A by B, and we get another matrix C, where here we have C has a column matrix with element C11, C12, go on until the element here this is we have N, and then here we have M1. Yes, okay, it's okay. This is an example of a matricial operator. Okay, now we will beginning with the operations with with operators. We will talk about a sum and identity on the next. Okay. Okay, one. Suppose that we have operator A and operator B. Then the sum of A and B is also an operator. For example, C. We have here I plus B has equal to C. Example, if you have A equal to X and B equal to D over D of X. Here we have this has a multiplicative operator, and here we have this has a differential operator. And suppose now that our f function is equal to x power 3. Then the operator C, which is a result of a sum of operator A and B, is x plus d over d of x, which is also equal to d over d of x plus x. When the operator C acts on f function, we get x plus d over d of x. These are acting on x power 3. And we have now, we introduce this term in the bracket, and we get x times x power 3 plus d of x power 3 over d of x, and we have as the result, which is we have x power 4 plus 3 times x power 2. Okay, this is an example of a sum of an operator. Okay, of operators. Okay, we have, now we go on with the identity operator. Identity operator. As the name tells us, any identity operator, usually represented with I, is an operator that acting on F gives has also O again F. That means I acting on F, the result is F. Suppose, for example, our f function of x is equal to x, and our identity operator is 1. Then when I act on f, we have 1 times x, which is x. Suppose now that our g function is equal to a column matrix. Then we have x1 here, x2, x3 has the elements of the function g, and we have the identity matrix has 1 0 0 0 1 0 0 0 1. Then when we apply I on a function g, we get 1 0 0 0 1 0 0 0 1 times x1, x2, and x3 there, and has the rule of a product of two matrices we have here. We must multiply this line with this column to get the first element of the new column matrix, where we have 1 times x1 plus 0 times x2 plus 0 times x3. Here we can see that when we will multiply 1 by x1, we get only x1, and 0 times x2 is equal to 0, 0 times x3 also is equal to 0. Then we have only here x1. The same thing we must apply to the second line, to the same column, and we get only 1 times x2, and here we get when we apply the last line to the same column, we get 1 times x3, so that here we have x1, x2, and x3, which is equal to the g function, as we can see from here. Okay, this is an example of the identity operator. Okay, we go on talking about equality of operators and product of operators. Oh, okay. When can we say that two operators are equal? Equality of operators. Okay, two operators A and B are equal if A acting on f function gives us a function h, and also B acting on a function f, on the same function f, gives us a function h, the same function h. Okay, then we say that A and B operators are equal. We can show this, for example, if we can show that actually A is equal to B, for example, if we say that if H is equal to H, then these terms are equal, and we have A applied to on f function is equal to B applied on a function, so that we have A applied on f minus B applied on f equal to 0. And from here we can see, as we mentioned about the sum of two operators acting on the same function, then we have here A minus B applied to f has equal to 0, where we know here we are supposing that f of is different to 0, and if f is different to 0, then this expression here means that A minus B is equal to 0, so that we have A equal to B. Okay, we go on here. We are talking about the equality of operators. We go on talking about product of operators. Okay, a product of operator, for example, is if you have A and B, their product A times B is equal to C. So that, for example, if we have f function and we apply C on f function, we have the same thing as A acting on the function resulting of the action of B on f. Here is necessary, it's important to say that usually A times B is different to B times A. But as we go to see on the next part, which is the commutator, okay, a commutator is a mathematical object written on the bracket, a square bracket like this, A, B. This is the commutator of operator A and operator B. This operator has its definition as A times B minus B times A. This is the definition of a commutator. Okay, as we mentioned previously when we talked about the product of two operators, generally this product is different to this one, but there are a class of operators that satisfy the relation written as the commutator of operator A and operator B is equal to 0. If this expression is satisfied, then we say A and B commute between them. This expression has physical consequences, but for now we will not talk about this consequence. We go on, but you must remember here that two operators that satisfy this expression, we say that they commute between them. And if two operators commute between them, then this has a physical consequence, physical or chemical consequence. Okay, we go on. Now we was talking about commutator, and we go on the last part, which is the inverse of an operator, or inverse operator. We say that an operator L has its inverse operator L power minus 1 if the product between them is equal to the identity operator. Here, the first example that we can give, for example, is the identity operator. Suppose that our identity operator is 1, then we are saying that its inverse is also 1, because when we multiply I by its inverse, or also its inverse with I, it's equal to 1 times 1, which is equal to 1. Also, we can have, for example, the identity matrix of 3, which is 1 0 0 0 0, sorry, 0 1 0 0 0 1, and we are saying that its inverse is also 1 0 0 0 1 0 0 0 1. And here we will see that when we multiply I by its inverse, I power minus 1, we get 1 0 0 0 1 0 0 0 1 time 1 0 0 0 1 0 0 0 1. And using the previous rule where we multiply the first line by the first column, we have 1 times 1, it's 1, 0 times 0, it's 0, 0 times 0, it's 0, then we have 1 plus 0 plus 0, we get 1. Also, we use this line and multiply with the second column, and we get 1 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. Then we have the second element in this line has 0. On the other hand, we go on multiplying the same line with the last column, and we get 1 times 0 is 0, 0 times 0 is 0, 0 times 1 is 0, and we have here 0. And here we must multiply for the second line. We must multiply this line by this column, and we have 0 times 1 is 0, 1 times 0 is 0, 0 times 0 is 0, we have here 0, and we have here 0 times, or for the second element of this line is we have okay, this line times this column, we have 0 times 0 is 0, 1 times 1 is 1, and 0 times 0 we have 0, so that 0 plus 1 plus 0 is 1. Here we have 0 0 0 1, as you can using the same procedure to get this result. And as we can see here, when we multiply this matrix with its inverse, we get the identity matrix as we can see here. Okay, then thank you for watching this video. Again, I'm asking you to put like in this, share with your friends, subscribe in our channel. We will continue publishing putting in this channel videos that will help you and everyone needing for helping in these kinds of content. Thank you. See you on the next video. Bye.